Welcome guys to my channel. This is Chemistry with Min. Today,
Today's topic, we will discuss gas law, its theory, and its behavior. Properties of gas. Most gas exist as molecules. The molecules of most gases are randomly distributed and are far apart. Gases can be easily compressed. Remember the first lecture that we have, one of the characteristics of gas is that the molecules are far apart. Gas doesn't have a definite shape and volume. They will fill any container that they were placed. Gas have lower density compared to solid, liquid, and gas. The attractive force between molecules are negligible. So most substances that are gaseous at normal condition have low molecular mass. Gas that have gas has high molecular velocity. Remember that. That's why they're fast. And gas can diffuse readily and fill up the available space. Kinetic molecular theory. So, according to kinetic molecular theory, gases, gas particles do not attract or repel. Gas particles are smaller than space between them. Gas particles are in constant random motion. No kinetic energy is lost when a gas particle collides. All gases have the same kinetic energy at a given temperature. We have several gas laws: Boyle's law, Charles' law, Gay-Lussac law, Dalton's law, Avogadro's law, combined gas law, and ideal gas law. So later on, we'll discuss each one of them and what's the difference between Charles' law and the rest of the gas law. Okay, let us start. What is the difference between ideal gas and real gas? So, ideal gas obeys the ideal gas law always, while real gas only at very low pressure and very high temperature. Meanwhile, the molecular volume of an ideal gas is always zero, but real gas is just small but non-zero. For molecular attraction, ideal gas is zero always, and the real gas is small. Molecular repulsion, ideal gas is always zero, and real gas is always small. Okay, guys, memorize this. This is very important. This is the standard temperature and pressure. So the standard pressure is 1 atm, volume is 22.4 liters, mole is 1 mole, temperature is 273 Kelvin, and rate is 0.0821 atm. So this is constant, the R, okay? So memorize this. This is really important to some of the problems. Boyle's law was founded by Robert Boyle, and Boyle's law is about pressure and volume are inversely related at constant temperature. So the formula for Boyle's law is P1 times B1 is equal to P2 and B2. So if B1 increases, then B1 increases, then pressure will decrease. So if pressure decrease, volume will increase. As you can see here, if P1 increase, volume will decrease. Okay, let's try to solve some problems right now. So, a balloon with a volume of 2.0 liters is filled with a gas at 3 atmosphere. If the pressure is reduced to zero point 0.5 atmosphere without a change of temperature, what would be the volume of the balloon? So we know that we're gonna use Boyle's law because there's a constant pressure, constant temperature, while there is a change in volume and pressure. So let us set up the equation. So first step, put the given. Okay. Our given is given. Sorry. Given. Our given is P1 is 3 atmosphere, B1 2 liters, P2 is 0.5, and missing is B2. So what will you think will happen? Will the volume increase or decrease? The volume will increase if you reduce the pressure. So let's check if it's that true. So P1, B1, P2, B2. So P1, B1 over P2. Then let's sub input the values. Okay, 3 ATM times 2 liters divided by 0.5. So the answer would be B2 will be 12. So what's the unit? The unit is liters, so it will become 12 liters. All right, let's try another one. Let's try another one. So if a gas is at 25 Celsius, occupying 3 liters at pressure of 1.1 atm, what will its volume at the pressure of 5 atm? All right. Similar to the first one. All right. So let's let's do the given. P1 is 3. P1 is 1 atm. B1 is 3 liters. B2 is 5 liters. And B2 is missing. B2 is 5. Yeah. So let's set up the equation. We know that it's constant pressure, so we're going to use Boyle's law. So B1 equals B2. So we transpose this. We just want this alone. And then substitute the values. Liter. So what would be our final answer? Our final answer would be 0.6. So our final volume is B2 is 0.6. Correct? If you increase the pressure, what will happen to the volume? Will decrease. Okay. Let's try one last one. So let's gas occupies 2 liters at 1 atm. What will be the volume of this gas if the pressure becomes 3 atm? Right. Let's do this again. So let's do this again. Okay. Given is B1 is 2 liters, B2 is unknown, P1 is 1 atm, and P2 is 3 atm. So formula is this. 2 would, so 2 times 1, 2 divided by 3, that's 0.66 liter. And that would be our final answer. Charles' law was founded by Jacques Alexander Charles. So Charles' law is about when volume of gas varies directly with the absolute temperature at constant pressure. So it means if volume goes up, then temperature will also go up. If you increase the temperature, that volume will also go up. If you decrease the volume, temperature will also decrease. Okay, let's try to solve some problems. Okay, for problem number 1, calculate the decrease in temperature when 6 liters at 20 Celsius is compressed to 4 liters. So, first step, find the given. All right. So we know, okay, given. Okay, now, okay, given. And then volume number 1 is 6 liters. Volume number 2 is, and volume number 2 is 4 liters. Temperature number 1 is 20. And what is missing is T2. So we're going to use Charles' law here. So let's set up the equation. This is the formula for Charles' law. So B2. So we want this to retain, correct? So let's transpose it. So B1, T2, B2, T1, then T2 equals B2, T1 was B1. Now that we have this, let's substitute all the problems. So we have 6, we have 4 liters, which is B2, times 20 divided by 6 liters. Now that we have this, so that's 80 divided by 6. So what would be our answer? 80 divided by 6, that would give us 13. T2 is 13.33 Celsius. And that is our final answer. Okay, let's check out another problem. A container containing 5 liters of gas is collected at 100 Kelvin and then allowed to expand to 20 liters. What is the new temperature to be in order to maintain the same pressure? All right. We need to use Charles' law because we want the same pressure. So let's find the given first. Okay. Our given is B1, 5 liters. T2, T1 is 100 Kelvin. B2 L, 20 liters. Okay. T2 is missing. Now, let's set up the equation. Remember, the equation that we have, we want to find this, remember. So, that would be B1 divided by T1 is equal to B2 over T2. B1 T2 equals B2 T1. Alright, T2, B2, T1, T1. We'll use this equation. Alright, so let's substitute the values. So T2 is equal to 20 liter times 100 divided by 5. So we got 2,000 divided by 5, 400 Kelvin. And that would be our answer. And let's try one last problem. All right. A gas occupies 900 milliliters at a temperature of 27 Celsius. What is the volume at 132 Celsius? All right. Let's do this. So let's find the given. Given is B1 is 900 millimeters. T1 is 27 Celsius. B2 is missing and T2 is 132 Celsius. Okay, let's set up the equation. So B1 divided by T1, B2 divided by T2. So B1 T2 over T1. This is the equation that we're going to use. And then let's substitute all the values. So 900 times 27, times 132 divided by 27 equals B2. All right, let's calculate it. 900 times 132 divided by 27, we will have 4,400 milliliters. And that would be our final answer. Gay-Lussac law was founded by Joseph Louis Gay-Lussac, and Gay-Lussac law states that at constant volume, pressure and absolute temperature are directly related. So for the formula for Gay-Lussac law is P1 over P1 is equal to P2 over T2. So if pressure increase, the temperature will also increase. If the temperature decrease, the pressure will decrease. So basically, they're directly directly related to each other. The gases in hairspray are at temperature of 27 Celsius and a pressure of 30 atm. If the gas in the hairspray can reach a pressure of 90 atm, the can will explode. To what temperature must the gas be raised in order for the can to explode? Assume constant volume. So let's try to solve this, guys. So let's find the given. Given is temperature is T1 is 27, P1 is 30 atm, temperature 2 missing, and pressure 2 is 90 atm. So, and volume is constant. So we're gonna use Gay-Lussac law. So which is P1 over T1, P2 over E2. So let's multiply it. P1 T2 over equals to P2 T1, T2 equals P2 over T1 over T1. Then let's substitute the values, which is P2 equals 90 times 27 divided by 30, which is 81 Celsius. And that would be our final answer. Okay, now that we have this, let's try another problem. Okay, Maybelline's backup oxygen tank reads 900 millimeter mercury. While on her boat, where the temperature is 120 Celsius, when she dives down to the bottom of the unexplored methane lake on the recently discovered moon of Neptune, the temperature will drop down to 10 Celsius. What will be the pressure in her backup tank at, at that temperature? All right, let's try. Let's, let's try to find the answer. So the given is temperature 1 is 120 Celsius. Pressure 1 is 90 millimeters. Okay. P2 is 10 Celsius and P2 is unknown. So P1 over T1 equals P2 over T2. We want to find the P2. So we're going to use this equation. P1 T2 over T1 times P2. So P1 is 120 times 10 divided by 90. So 120, so 120 times 10 divided by 90. Oh, sorry. I made a mistake. All right. Wrong substitution. Should be 90 divided by 120. There we go. So 90 divided 90 times 10 divided by 120. The temperature would be 7.5. Oh, sorry. The pressure would be 7.5 mmHg. That would be our pressure. So this is pressure, temperature. All right. Combined gas law. So the combined gas law combines the three gas law: Boyle's law, Charles' law, and Gay-Lussac's law. It states that the ratio of the product of the pressure and volume and the absolute temperature of the gas is equal to a constant. So the formula for combined gas law is P1 times B1 over T1 is equal to P2 times B2 over T2. A balloon has a Okay, before we start, a balloon has a volume of 100 liters when the temperature is 50 Celsius and the pressure is 400 milli, mil, millimeters of mercury. What will its volume be at 20 Celsius and 700 millimeters of mercury pressure? All right. Let's try to solve this problem, okay? Okay. What's the given? Okay, the given is B1, which is 100 liters. T1 is 50 Celsius. Pressure 1 is 400 millimercury. B2 is missing. Um, B2 is 20 Celsius and pressure is sorry, pressure would be 700. There you go. So the formula that we're gonna use is ideal combined gas law. So this is the formula for ideal gas law. So we're missing this. So let's set up our formula. 2 over P2 T1. That is our formula. We just transpose everything. We just need to leave this alone, okay? So pressure number 1 is 400. B1 is 100. T2 is 20. P2 is 700. And T1 is 50. Okay, let's solve this. So 400 times 100 times 20. Now, divide this by 3,500 because 700 times 50, that would give us 35,000. 35,000. So the final answer would be B2 would be 22 liters. That would be the final answer. Okay, let's try another one. If 10 liters of oxygen at STP are heated to 512 degrees, what will be the new volume of the gas if the pressure is also increased to 2 atm of mercury? So we want to find the volume. So the STP of so B P1 is 1 atm. That's the standard temperature and pressure. So P2 would be 25 Celsius. B1, sorry, P1, P1, B1 would be 10 liters. So let's try this. So P2 would be 2 atm. Temperature would be 500. And B2 is missing. So what would be our formula? Remember, we're going to use gas, combined gas law. So P1, B1 over T1 equals to P2, B2 times T2. So we're missing this. We just want this. So it would be P1, B1, T2 over T1 times T2. There you go. And then let's just substitute the value. So P1 would be 1. B1 would be 10. And P2 would be 520 divided by 25 times 2. All right. So 500 wood. So 5120 divided by 50. So B2 would be 102.4 liters. Okay, that would be our final answer. ideal gas law has the formula PB is equal nRT. R is 0.8206. So that's the ideal gas law. Okay, let's try to solve some problems. If I have 4 moles of gas at a pressure of 5 atm and a volume of 12 liters, what is the temperature? So we're going to use ideal gas law. But first, let's set up the given. The given is 4 moles. There you go. Pressure is 5 atm. 12 liters of, which is the volume, 12 liters. Temperature is missing. So the formula for ideal gas law is PB equals nRT. R is constant. Okay. Okay, let's do this. P is equals to 5 atm. So we just want this alone. So let's set up it first for you to see. So 5 nRT T. Okay, so 5 atm for the P, 12 liters. So the mole is 4 mole, and the rate, the R, the rate, so it's okay. So the ideal gas law is, just give me 1 second. So it's 0.08 liters atm over mole times. So the value of R is 0.082. Now that we have this, let's multiply. So 60 divided by 4 times 0.082, which is 0.3, sorry, 0.32. So 60 divided by 0, oh sorry, 60 divided by 0.32 will have 187.5 Kelvin. And that would be our final answer. Okay, let's try another one. If I have two moles of gas held at a pressure of 70 atm and a temperature of 90 Kelvin, what is the volume of the gas? So let us set up the equation. We know R is a constant, so 0.082 liter per atm over K mole. Okay, and then we have pressure, which is 2 mole, which is 70 atm. This is 70 there, 70. Then mole is 2 moles. Then B is missing, and temperature is 90 K. So the equation is PB is equals to nRT. Now we just want this. So the equation will be B is equals to nRT over P. So let's substitute the values. So 2 times 0.082 times 900 Kelvin is equal to divided by 70. Let's solve this. So 2 times 0.082 times 900 divided by 70. So we'll have volume for 2.1 liters. And that would be our final answer. Graham's law is the diffusion rate of a gas is inversely proportional to the square root of its smaller mass. More massive particles move at a slower velocity than less massive particles. So the formula for Graham's law is R1 over R2 is equal to molar mass 2 divided by molar mass 1 of its square root. So how did we arrive for the equation for Graham's law of diffusion? So we use the kinetic energy A and kinetic energy B. So you just need to do a lot of transposing and we'll arrive at this answer. Determine the rate of diffusion for helium and oxygen. So we're going to use Graham's law for this problem. So this is the formula for Graham's law. So let's find the given. Okay. So given number 1, which is helium, given which is helium. What's the molar mass of helium? 2. That's the molar mass of helium. And then what's the molar mass of oxygen? 16. But there's 2 oxygen. So that would be 32. So let's substitute everything. So B will be 32 over 2. So that would be 16. So the velocity would be 4 meters per second. And that would be our final answer. This is the rate. All right. Let's try another one. So we're going to use this formula again. So B1 over B2 is equal to MB over MA. So how would we solve this? So B1 is unknown. B2 is 10 meters. B2 is oxygen, and 8 hydrogen. So molar mass of hydrogen is 1, and molar mass of oxygen, which is 16. Remember, there are 2 oxygen. Oh, sorry, 32 times 2, so basically 32. Now, we solve everything. So B1, B2, B2 is 10 meters per second is equal to 16 over 1. 15 over 1 would be 4 because of the square root. So now that we have this, so V1 over 10 meters per second is equal to 4. We transpose this here. So the velocity would be 4 times 10. And our final answer would be velocity 1. Our final answer would be 40 meters per second. And that would be our final answer. Avogadro's law was founded by Amadeo Avogadro, a physicist. So Avogadro's law described at constant temperature and pressure, the volume of gas is directly related to the number of moles. So if you increase the number of mole, the volume will increase. If you decrease the number of mole, the volume will decrease. If you increase the volume, the mole will also increase. If you decrease the volume, the mole will also decrease. So just remember, if, if volume increase, mole also increase, and vice versa. Dalton's law was founded by John Dalton. So Dalton's law is about the total pressure in a container is the sum of the pressure each gas would exert if it were alone in the container. The total pressure is the sum of the partial pressure. So P total is equal to P1 plus P2 plus P3. So that's the formula. Here is a summary of all the equations that we used for this chapter. So memorize this and you'll do fine.